In this video, we're going to take an in-depth look at Java strings. Working with strings in Java can be a little confusing at first because they really are a special case. Strings have associated with them this concept of a string literal, a sequence of characters between double quotation marks that we can just put right into our Java programs and Java understands it, just like it would understand an integer number or a single character. But unlike integers and characters and floats, Java doesn't have a primitive keyword associated with this string literal. About the closest we could get if we wanted to is character array. But generally, Java likes us to associate string literals with the string class. The string class in Java is special. In some ways, it's just like any other class. It has methods and, as we can see in these two lines here, it has a constructor. But we can use operators on the string class that are normally only reserved for literals and primitives. For example, we can add S1 to this string literal right here and get a meaningful result. This is not normally an option when we're dealing with a Java object. Java's decision to use objects of the string class as either string literals or genuine objects interchangeably is really powerful. It gives us way more options when manipulating text than we would otherwise. But it does come with some trade-offs. It's very important that we understand when we're dealing with a string object if we're dealing with its string literal value or with the object itself, because we can get radically different behavior. This program I've set up here is designed to illustrate one of these instances. It's a pretty simple program. Let's step through it and attempt to anticipate its output. We start off by declaring and instantiating two string objects, S1 and S2. We use the string constructor, and we'll talk about why that's important here in a moment. And we simply pass in the same string literal value to each of these new objects. Then we ask our program to print out these values just so we can compare them visually. But then we ask our program the interesting question. We ask our program to compare using the double equals sign comparison operator, S1 and S2. Before I run this program, let's take a second and ask yourself, what do you think the result of this comparison is going to be? When I do run this program, we see that Java does not believe that the comparison of S1 and S2 returns true. We get the result false. Depending on how we as people were thinking about S1 and S2 at the time, this either makes sense or is confusing. If we were thinking of S1 and S2 as string literals being compared with this operator, it would be very confusing to us why we didn't get the result true, because these string literals are the same. However, if we were thinking of S1 and S2 as the objects that they are, the result of false makes a lot more sense. Because what we're asking Java is, are these two objects the same? And they're clearly not, because they're both the result of creating two different new objects. This is why we like to use the equals method when we can in Java. Almost every object implements a .equals method. And the .equals method should be written for every object so that it logically compares the value of these objects. If we compare our strings using the dot equals methods, we're now comparing the string literal values they contain, and we get the result true, as opposed to the result false we got when we were trying to see if they were actually the same objects stored in the same location of memory. So what powers does this string implementation give us? Well, we know that we can add or concatenate strings together because we can manipulate them as literals. In addition to this literal manipulation, we can also make use of all the functionality provided by the string class itself. We can go to the docs to see what functionality is available for us, or we can always just check code quick completion. I should probably point out here that we can even use the string class functionalities on string literals. So a lot of these methods are pretty self-explanatory, to lowercase, to uppercase. But just to make sure we're all on the same page, let's make use of one of them. Let's use replace. Replace takes two arguments, and these arguments can either be single characters or a character sequence, of which a string qualifies. And this method simply replaces all instance of the first string or character with the second string or character. And so when we run our program, we see that we've modified its output. Most of these methods simply modify the value being returned. We can see that our program still finds that S1 equals S2 at this last line of code, showing us that the value of S1 hasn't been modified by our call to the replace method. Replace method has simply returned the modified value for our printline function to utilize. But perhaps the most interesting of the string class's methods is actually one of its static methods. This is string.format. To show you the power of string.format, I'd like to create a brand new functional class for our project. We'll call it custom printer. And so that you can see what we're doing when we set this class up, let's pre-write the code we're going to use in our main method. The idea behind the custom printer class is that we can create a new custom printer, and it will have a constructor that takes a string as input. And this input string will format or wrap around any strings that we use the custom printer to print out to our console. And we'll implement system.out.println within the custom printer. So we can just call printer.println when we want to utilize it. When we're formatting a string in Java, we're going to use some special syntax. Within our string, we can preface the characters F or D or S most commonly with a %sign. And Java understands these in terms of the string.format function, which we're about to use, to be areas in our format string where we're going to insert other information. This format string that we're going to use here will wrap any string output we create with these nice little caret brackets. This is more complicated than simply appending and prepending to a string. And we could certainly create an implementation that allowed us to add multiple pieces to our formatted strings. And we'll just get rid of that for right now because that's not going to end up working. And let's go to our custom printer implementation. We know that we're going to need a constructor which takes a format string as input. And then we're probably going to need to store this format string. So let's just have our constructor take the provided format string and store it for later use. We also declared a println function, which presumably is going to be a void function and is just going to utilize system.out.println to print something to the screen. What that something is, though, is going to be a little complicated. We need to take our given format string and replace that %s with the provided input to our println function. We do this with the awesome string.format static function, which takes a format string and then the replacing arguments as parameters. If our format string had multiple blocks to format, for example, multiple insert strings, we could provide multiple fields in string.format. It's a function that can take any number of inputs. But to keep everything simple and moving along, we're simply going to assume that our format string only has one input instance. And then once we successfully formatted this string, we'll simply print it out to the screen as we would earlier. When we run this program, we see that all our output gets properly wrapped with these caret brackets. A custom printer like this is the basis, once it's extended, of course, to take more varied input and be much more dynamic than this quick thing we created here, is the basis for anything like a logging system or a terminal system, where you see the same pieces of information wrapped around messages. We could use a custom printer like this, for example, to place dates and times after any message we send to the user, properly formatted so that they're not just tacked on at the end, but have proper spacing between them and stuff like that. I hope you all learned something about strings. The way Java handles them is really powerful, but as with most powerful things in programming, you need to understand them on a basic level before you can be sure that they're not going to come back and bite you. See you next time.